Okay, ever stop and wonder what really makes a modern factory tick? I mean, deep down. We're about to pull back the curtain on a piece of tech you've probably never even heard of. But, and I mean this, it powers almost everything around you. So, let's dive into this kind of hidden world.
Yeah, it totally sounds like the start of a riddle, right? A huge power plant, a gritty steel mill, and the car sitting in your driveway. What could they possibly have in common? Well, the answer is this. Surprisingly tiny little component. It's like the invisible backbone of, well, all of modern automation.
Yep, the answer is something called an inductive sensor. And you know what? For this explainer, we're going to treat it like the hero of our story. Because honestly, it is. This tiny little device is basically the sensory organ, the eyes and ears, for pretty much all modern machinery, just working away tirelessly behind the scenes.
And I'm not kidding, there are millions of these things. They are absolutely everywhere. Think about assembly lines, packaging plants, huge construction equipment. They're in all of it. Their job sounds simple, but it's so crucial. Just detect when a metal object is nearby. But here's the really cool part, the magic trick, if you will. They do it without ever touching a thing. Not one.
Okay, so how on earth does it do that? Well, every good hero needs a superpower, right? And this little guy's power comes straight from the world of physics. It's got this kind of electromagnetic sixth sense that lets it see metal using a completely invisible field.
So, let's break down this superpower. It's actually really cool. The sensor shoots out this high-frequency electromagnetic field from its face. Just picture like an invisible bubble expanding outwards. Now, the moment a metal object gets into that bubble, it causes these tiny little electrical currents to swirl on the object's surface. They're called eddy currents, and these currents are like tiny energy vampires. They suck just a little bit of energy out of the sensor's field. The sensor immediately notices that tiny dip in energy and, bam, it triggers a signal. Metal here. It's all so simple, but it's also elegant and happens in a flash.
So really, the bottom line is this. It's a gadget that detects metal without touching it. Simple as that. And because nothing is ever physically bumping into it or grinding against it, these things are just incredibly rugged. I mean, they're built to last for millions upon millions of cycles without even breaking a sweat.
But hey, just being tough isn't enough in the modern world, right? Our hero also has to be smart, and this is where SICK's real secret weapon comes into play. It's called an ASIC. That stands for Application-Specific Integrated Circuit. The easiest way to think about it, it's the sensor's entire brain, all squeezed onto one single tiny little chip.
And here's why that little brain is such a big deal. With the old school sensors, you had to tune them by hand, and honestly, no two were ever exactly the same. It was a real pain. But with an ASIC, every single sensor is digitally calibrated right at the factory. So what does that mean for you? It means if one of them ever breaks, you just grab a new one, plug it in, and it will work perfectly, identically to the old one. We're talking down to the micrometer. No fiddling, no readjusting. And in a factory, that means less downtime. And trust me, that is a very big deal.
So, check out this number. Less than or equal to 2%. What on earth does that mean? Well, that's its reproducibility. It means that the exact point where the sensor decides, yep, there's metal here, will vary by less than 2%, not just over its entire life, but across millions of different sensors. That is just an insane level of precision and consistency. And it's all thanks to that little brain on a chip.
Okay, so our hero is smart. We've got that. But industrial environments, man, they can be absolutely brutal. We're talking extreme heat, freezing cold, constant moisture, and just non-stop vibration. So to survive on what's basically an industrial battlefield, this sensor needs a serious suit of armor.
And believe me, what a suit of armor it has. The housings are made of tough stuff like nickel-plated brass or stainless steel, so they can really take a beating. Some even use this special glass fiber reinforced plastic called Vistal, which is way tougher than your average plastic. Then, on the inside, all the electronics are completely sealed up in this stuff called hot melt. It basically makes them immune to shock and vibration. Oh, and you see those IP ratings? That's just a fancy way of saying you can dunk these things in water, blast them with a high-pressure hose, and they'll just keep on working. It's wild.
Another really clever part of this armor is actually its sensing distance. See, SICK has figured out how to make sensors that have double, triple, or even quadruple the normal sensing range for their size. Now, why is that such a huge deal? Well, it means engineers can mount the sensor much farther away from all the dangerous moving parts of a machine. That drastically cuts down the risk of something accidentally smashing into it, which, you guessed it, prevents super expensive downtime. Okay, so all this tech is seriously impressive on paper, but let's see how our hero actually performs out in the real world. We're going to look at 2 missions, if you will, where these sensors were really put to the test.
All right, first stop, China. We're at a massive pumped storage power plant. The mission? To keep an eye on the speed of a gigantic generator rotor, and it had to be with perfect accuracy. I mean, if you get this wrong, you're looking at potentially catastrophic failures. And the environment was just awful for a sensor. Tons of electrical noise and physical shake.
And mission accomplished. The SICK sensors performed so flawlessly that the customer, a company called Nari, immediately decided to start using them in a bunch of their other high-stakes projects. I mean, come on, that is the ultimate vote of confidence right there.
Okay, next up we're heading to Turkey. We're at a company called Göçmaksan Machinery, and they build these absolute beasts of machines that bend steel. Here, the sensors had a critical job, detecting the exact bending angle every single time. And this is a seriously tough gig. There's constant, heavy vibration, and metal dust and debris flying everywhere.
And the result? You guessed it. Perfect reliability. In fact, the sensors worked so well that they became linked with the machine builder's own reputation for quality. Think about that. When your little component actually helps uphold your customer's entire brand name, well, that's when you know you've really nailed it.
But look, the story doesn't just end there. Our hero's journey is really just getting started. Because as the entire world shifts into what we call Industry 4.0, you know, the age of smart factories, our little sensor is evolving right along with it.
Get this. Our hero is learning to talk. Seriously. Through a technology called IO-Link, the sensor is transforming from just a simple on-off switch into a genuinely smart device. It can now actually communicate, sending a whole treasure trove of data back to a machine's main controls.
And this is a total game changer. The sensor can now tell you what its internal temperature is, it can warn you if it's starting to vibrate too much, it can even tell you if its vision is getting blocked by dirt or debris. This all leads to something called predictive maintenance, which is all about fixing problems before they shut down the line. And that, my friends, is the holy grail of modern manufacturing.
So, we started with a simple little riddle about what connects our world, and we ended up here. We've seen this thing go from a silent, tough workhorse to a smart, communicative partner in automation. It really makes you think, doesn't it? If a component as simple and fundamental as this can become so intelligent, what does that mean for the future of the entire automated world? What's the next big leap in this evolution?